Hi everyone, my name is Caden and this is my presentation for the gene identification course project. So going right into it, I was assigned nucleotide sequence number 10. This is the untranslated sequence and it's the start to my analysis and finding out what my gene is and what its function is. So the first program I ran was the BLAST10 and this essentially was taking my nucleotide sequence and it was searching it into a nucleotide database. So the purpose here was to find 5 related species and 1 unrelated species. So you can see the unrelated here in this bottom right hand corner. It told me a lot of good things. So it told me the scientific name of each of them, the percent identity, so how much it is actually related. And then it also told me the GenBank accession number, which is a specific number for each of them that I could use in future analysis. So using those GenBank accession numbers, I was able to do the BLASTX analysis. This is a search that's going to take that untranslated sequence and it is going to translate it and search it into a protein database. So I put my nucleotide sequence in it, I did the align2 function, took those GenBank accession numbers and searched them against my sequence. From there, it would tell me my percent identity, so my amino acid percent identity, and then it was able to actually tell me what the protein ID is. So I'd go into each of these and I'd find the range that my sequence is found and take the protein ID number and kind of get an idea of what the protein is for each of these that it's found in. So next I went into the Open Reading Frame Finder, which is a separate program. And this actually told me a lot of good things. So first it translated my sequence, and I'm going to use that translation for a lot of my future analysis. It also told me things such as the nucleotides, the amount of amino acids, all that stuff. But also I was able to go into each of these ORFs and find where my gene specifically is. And this was my first hint to actually finding out what my gene actually codes for. So in my BLAST10, I saw a lot of time it was saying that it was the nucleocapsid protein. So now going into a separate program, I also found out it was the nucleocapsid protein. So this was my first way of verifying what my gene actually codes for. Next, I did the BLAST-P in conserved domain database. So the BLAST-P was just essentially it's another way of getting the amino acid identity, just a more accurate reading on it. So it took that translated sequence and it searched it into a protein database. So it was a protein to protein search, and it kind of just gave me more accurate readings. So you can see a lot of times they lined up with each other, but there's a couple here that's just a couple percent off. So I was able to update those numbers. The conserved domain database. So the purpose for this one is to find out if there was any motifs that was in my gene. Unfortunately, I did not get any hits on this one, but that's likely just due to the limitation of the database itself. It's likely not been characterized yet. So next was the transmembrane helices hidden Markov model. In this program, what it's doing is it's using that translated sequence that I got from the ORF finder, and it is searching to see if my protein actually has any transmembrane proteins. If you're looking at the graphic here, it may look like I didn't have any results, but it actually gave me a negative result. That tells me something, right? So it tells me I don't have any transmembrane proteins. Okay, so going into signal P. So this is basically predicting if I have any signal peptides. The results here, as you can see up here, is well below 1%. So it's saying the likelihood of me having a signal peptide is not at all. So I don't have any signals that's going to excrete or transport it anywhere, such as like the membrane or anything like that. Next, I used a program that would build out a phylogenetic tree. So what I did here is I took all of my translated sequences, I put them in a Word document in FASTA format, plugged them into the program here, and it was able to build this tree for me. So it took my 6 related sequences and my 1 unrelated, and it showed me just where they line up on that tree and how related they are. So the fire analysis, what this one does is it predicts a 3D model of what my protein actually looks like. And also it gives you like a confidence interval, the alignment coverage to it. And yeah, this is just another good way of kind of verifying what your actual gene is. So you can see here again that nucleocapsid protein. So finally, as my end result, I came to the conclusion for the gene identification that I had the nucleocapsid protein. So my gene codes for that nucleocapsid protein. And what this protein consists of is it is a capsid enclosing the nucleic acid of a virus. So it is a viral gene. And this is actually responsible for the packaging of viral genome nucleic acids. And what it does is it will actually enwrap the RNA itself and form a complex that will then act as a template for viral replication. So it's actually found in quite a bit of common viruses. So you can see here it's found in the COVID, influenza, and HIV. But yeah, that is my gene identification. Let me know what you guys think.